So good evening all and welcome to this live session for the business analytics course. I'm Swaminathan, one of the co-instructors of this course. Shall we start the live session or shall we wait for a couple of more minutes? Hello, am I audible?
Yes, sir. Good evening. You are audible, sir.
Thank you, thank you. So shall we start?
At least we can start, discussing couple of generic points, and then once people join, then we can wait for 5 more minutes to join more people.
Sure, sure. So right now you are in week 4, right? Simple
Right,
linear
sir.
regression.
Right, sir.
All right. So how is the course so far? First, it started with the uh, dashboarding visualization, then chi-square goodness of fit, then chi-square
Right.
test of independence, now simple linear regression. How do you find the course?
Yeah, it's going good, sir.
Okay. And
So the
did you meet
first,
Rahul sir in the live session? Did Rahul sir join in any of the live sessions?
I have not met, sir. So others can
Okay.
chip in and share their views.
All right. All right. So I think Rahul sir will join next
Today?
week. Next week,
Okay.
maybe next week. You can meet him next week.
Yeah, sir. Where can we get those earlier? I think three classes have happened so far, right?
Okay. Hmm.
Where to get those recordings, sir?
I'll find it out. I'll update in the
Because
forum
the
discourse.
link given in the calendar, once
Hmm.
we click that, so it's not opening. It is still saying that the meeting date scheduled so and so, like that. All those informations. And
Okay. Okay.
do we have a separate YouTube channel for this course, sir?
Yes. Yes. Definitely. For business analytics, there is a separate YouTube channel available.
So I think there is some spelling error also. So it will be better if we can correct that also. The spelling of analytics is wrong, sir, over there. But
Really?
any,
Okay,
yeah.
let me note it down because I just saw, even I was seeing a couple of videos before this session. It was okay.
Uh, no,
Let
I think,
me.
yeah, I
Okay.
think so. Yeah, in place of Y, it is A itself. I just checked in calendar.
Okay.
Yeah, yeah.
Sure, sure. So this is, you're in the right track. You're paying attention to details. So this is what business analyst.
It was just a coincidence that I was able to
That is
capture
the
that.
that is the job of a business analytics. Finding
Hmm.
faults, finding patterns. All right. So today's session will be very short. So we will primarily focus on the week 4 contents, which is a simple linear regression. The agenda for this session, we will start with a simple Python tutorial of a simple linear regression. And we'll see how this business analytics way of looking at problems is different from other courses. So you might be doing other courses like machine learning fundamentals, machine learning theory, practice, and so on. So how is business analytics different from these courses when we are solving problems in regression, classification, and so on? That is one thing. Second thing, we'll look at the challenges the industry people are facing when doing a regression problem and so on. We'll also look at that. And finally, we will talk about the assignments, do's and don'ts, which is scheduled for the upcoming week. So this is going to be the short agenda for today's session. We'll start with the Python tutorial on simple linear regression. This will be slightly different from the one that you already have on the uh, course portal, right? Uh, is my screen visible?
Yes, sir.
Okay, I'll
Yes, sir.
zoom it up a bit. As usual, the regular formalities, I'm importing pandas, numpy, and from sklearn, I'm importing linear model, and we'll also plot some things and see. I'm reading this particular CSV, which is savings.csv. If you look at this data frame, as I said, it's simple linear regression. It is only going to have one independent variable and one dependent variable, year and savings.
Excuse me,
And
sir.
yes, yes.
Sir, I believe last week's live session has not been uploaded, sir.
Okay, I'll make sure that it gets uploaded. I'll talk to the admin and get it uploaded.
Kindly do
Thank you
for
very
all the
much, sir.
three classes, sir. Huh?
Yes, yes, I'll make sure I've noted down. All 3 live sessions will be uploaded with the link. Fine, shall we continue?
Sure.
Yes, sir.
Okay. So as the name suggests, simple linear regression, we'll have one independent variable and one dependent variable. So we'll also see the shape of this data frame. So it's a small data set, relatively small data set. You only have 47 observations and two columns. And if you plot this data frame, you could see a increasing trend, right? I think in the tutorial what Rahul sir was teaching, you had demand and price, right, as the two variables where you had price and demand, and it was a decreasing trend. So this is an increasing trend. So this data set comes from a particular person who has been saving money since 1965 to 2011, I guess. So every year he has been doing some savings, and we are going to predict what are his savings going to be in the upcoming years, right? So as usual, I'm splitting data into X and Y. So X is nothing but your year, then your Y is nothing but savings. So this is your Y. And once you have X and Y, I'm directly fitting the model. I'm building the model using this linear model, linear regression. So this is present under sklearn. I'm just fitting the model, and then I'm going to predict the salary, predict the savings. Let us say 2020. So this is the savings that this person will have in 2020. So what if I give 2016? It's going to throw me some result, right? So if you want to see it as a proper integer, let's do that. This is the savings the model is predicting for 2016 and so on. So how this is predicting that you already know. You have an intercept, you have a coefficient. So let's take this. So intercept, this is negative beta naught plus beta 1 into, let's say, 2016. This is what your model also predicted. And since rounding it as an integer, we are getting round values. But this is how it works. Beta naught plus beta 1 into the feature value, right? What is this regression score? Can anybody say? Reg dot score is 0.9. How did you get this 0.89? Any guesses? Okay. So are you aware of correlation?
Yes, sir, I was
Yes,
coming to
sir.
that. It's a part of correlation coefficient. Yes.
So this could be correlation.
Yes.
Okay. So let us see what is the correlation. So this is the data
Is it the
frame.
square of correlation coefficient?
You are absolutely right. So if you see DF, this is the data frame. If you look at the correlation correlation in the data frame, you will have the diagonal. Diagonal is always 1. So this is the correlation between X and Y, 0.943884. So let me copy this. The square of this is 0.89. So that is what you have here. So what does this R square say? Can anybody say? So R square, it gives us the ability to explain variability in the target variable. So how good is your model is being tested by this R square. Higher the R square, better your model is, right? So let us do some interesting things here. So since I gave 2016 here, we got a nice value. What will happen if I give something like only 16? Is this value making any sense? So what is happening here? Whatever value, integer value you are going to give here, even if it is negative, your model will throw some output value, right? So what is happening here? Can anyone say? All right. So this is one question. You can think about this. The next question is, How do you know that the model, that the result you're getting 2016? So if you say I want to predict my savings for 2016 and getting 40,917, this is what my model is telling me. How do you know this is correct or not? So these are the two questions I have for you. Are you aware of some techniques to understand whether your predictions are correct? How close are you to the reality?
Error.
Error? Yes.
Checking the error.
Okay. Any other guesses? Any other suggestions?
Different forms of error only, like mean square error and all.
Beautiful, beautiful. So here you have just spoken about R square. So if you look at mean square error, mean absolute error, mean
Right.
absolute percentage error, so that could tell us. But right now, what you're doing here is you are not splitting it as test and train. So you are building the model on the entire
Okay.
data. So typically what you do, you split this into train and test. You build the model on the training data set, and then you um, test it on the test data set. In the test data set, if you put the model that you had built, these points in the test data set, the model has not seen it before. So therefore, if it is performing well on the test data set, you can be you can have some surety that your model is fine, right? And next thing I want to talk about is the challenges, right? For example, we spoke about the model score or R square 0.89. So do you think this 0.89 is a good score?
Yes.
Okay, so we spoke about mean absolute error, mean absolute percentage error. So let us take mean absolute error as 20% or 0.2, right? So in industry, the biggest challenge people face is that the base model will give us some performance around 20% as mean absolute error or mean absolute percentage error. So this is typically mean absolute percentage error. So improving this model from 20 to 19 is a very big challenge. Incremental improvement is going to be a very big challenge. The second big challenge is the size of data. So this particular model had only 47, 46 data points. So Pandas was easily able to build the model, test the model, and so on. But in industry, what is going to happen is you will have thousands of variables or hundreds of variables. The observations will be in millions. So in that case, even Pandas may not be able to efficiently handle them. So for that, we need take techniques like Spark or PySpark and so on. So two things, the industry faces two important challenges. Number one is improving model performance. That is improving MAPE from 20% to 19%, 19.5%, 18% is a big challenge. The second big challenge is scalability. So how do you handle huge data sets, right? So these are some of the things that industry people, they are also facing these kind of challenges. These are some of the questions even they are finding difficult to answer, and so on. Any question on this particular topic? Simple linear regression. The next topic will be an you will work on multiple linear regression, where you will have multiple independent variables and one dependent variable. Savings will be the same, but the independent variables will be not just one, it will be more than one. Can you think of some other independent variable that could contribute to predict savings? So we had a year as one variable. Can you think of other variables?
So there can be many things like
Yes.
monthly expenses, inflation rate.
Inflation rate. What else did you say? Very good. What else did you say?
I said monthly expenses, but even monthly expenses can be broken down into many components, like
Yes.
family members,
Yes.
So all those things.
Yes, you made a beautiful point. Family members, yeah, size of the family
Mm.
and how much this person is earning,
Yes, earning itself. Yes.
what is his age group,
Yes.
what is the gender, male or
Mm.
female,
Academic education qualification.
educational qualification. Yes,
Right.
beautiful. So once you have more and more variables, uh, that becomes a multi-linear, multivariate regression problem. So that's what you are going to see in the next module.
In the week 5, huh?
Yes, in the week 5, you will be seeing about multivariate regression.
Mm. Sir, yeah, taking reference
Yes.
from name, fundamental question is coming to mind. May I ask? Yes,
Yeah, yeah.
the
Tell
way
me.
we are, when we say the simple linear regression, right? So there are two important words, simple and linear. So as you rightly said that in next module, as you said, so we already came to know that we are now going to read multiple linear regression, right?
Yes.
So there can be non-linear also, like polynomial and all, and then something like that.
Yes.
Okay.
Yes. Definitely. Definitely. So here we say linear regression because,
Hmm.
so if you see the model here, we are actually making an assumption that this data is linear. So the x and y are linearly correlated. So that's the bias we are introducing here.
But
You
it
will
is,
learn all.
but it is not coming, complete linear kind of thing. There are
Yeah,
ups and downs, right?
you're correct. So we are assuming it to be linear.
Hmm.
This
Okay.
actually may not be linear.
Hmm.
You might be correct. So for
Hmm.
that, if you look at our uh, if you look at the videos by Professor Rahul, he would have told you a few things. Uh, for the problem to qualify for a linear regression, you will look for certain things. You will see whether data is linear, number one.
Hmm.
You will check for errors. Are they independent? Is it having equal variance? Is it normally distributed? Are the errors normally distributed?
Hmm.
Right? Is the
Hmm.
mean zero, stand the variance constant, and so on. So before fitting a model,
Hmm.
you will have to make these tests. So this is
Hmm.
what, as a business analyst, you will be doing. First thing, understand the business problem. What are we actually doing? Second thing is asking more questions. The questions in the sense, what more features could be used for building this model? That is number one. Second thing, if you think this is a linear regression problem, you will have to make those tests. Whether is the data, are the errors independent? Are the variance equal? And so on. So those things will be covered in your preliminary courses, like statistical courses or other courses, the machine learning fundamentals and so on.
No, linear regression has not yet been covered in any course.
Okay, it has not been covered in any course.
No, neither in Stats 1 nor in Stats 2. I'm not aware about MLT because I'm
It is there in MLT, MLP.
Yes,
okay. It
it
is
is
there.
there in
Okay.
MLT, MLP.
Okay.
So brush up your other ML basic
Yeah,
skills as well.
in MLT we are in week 4, so till week 4 it has not come. So maybe that
Okay.
down the line it will come. Yeah.
Yeah. So those things you have to check whether the assumptions of linear regression are they valid for this problem or not.
Okay, so
That is one
we
thing,
are
right?
not going to cover those topics here, right?
So those will be very trivial because this is a business analytics course. So
Okay.
here we cannot teach you the tools.
Hmm.
So our emphasis will be on the business problem. The tools will be taught in other courses like
Correct.
MLT,
Got it,
MLP,
sir.
and so
Got
on.
it. No problem. So, sir, coming back to our main question, which I asked that what are different kinds of regression? Like we talked now that there will be multiple linear regression and then there will be non-linear regression, right? So,
Yes,
could you please
yes.
name some of the important topics which we should cover? Like,
Okay. You will have polynomial regression.
okay,
So you could have that is polynomial regression itself is going to cover multiple things. Here you are assuming x and y to be linear.
hmm.
So that could be non-linear. Non-linear in what sense? Is it? I mean, y is equal to uh, beta naught plus beta one x cube or x square or x power 4, x power 9. It could be anything, right?
Correct.
So
So
these are
when it is non-linear, it means it is becoming polynomial, right?
yes, yes.
Correct. Okay.
So all these things. So there are multiple ways. So I don't want to confuse you.
No, that's fine. Out of curiosity, I asked this question.
Yes. But the one thing I can tell you is you can convert a non-linear problem into a linear problem by doing some transformations. So that is happening in the industry. So let us say you have a non-linear data. By doing some transformations, you can convert the non-linear regression problem into a linear regression problem. That is also happening in the. That is very much possible. So all those things you will see in the advanced courses. All right, we spoke about the challenges. We spoke about simple linear regression, some introduction to multiple linear regression. The other thing is you have an assignment coming up in the next week, right? So the portions for your first assignment, which is going to be for 20 marks, will have two problems. Number one will be the goodness of fit. You will be given a data set. You will have to guess what distribution it belongs to. It could be uniform, it could be normal, it could be Poisson, and so on, right? You will have to guess what distribution it is based on the plots, histogram, and so on. And once you guess the distribution by means of these plots and descriptive statistics, you will have to perform a chi-square goodness of fit test and confirm your guess is right or not. That is the first problem. Second problem could be in test of independence, or it could be in simple linear regression. So the basic thing for your assignment is use only Google Colab for doing the assignment. So we had this problem. If you use different IDEs like Jupyter Notebook, Spider, Google Colab, PyCharm, and so on, the decimal places, the accuracy of your answers are slightly different. They are not very different, but we have challenges, right, in the online medium. So each of the IDE will have different versions. For example, this could be 3.7. The Python version I'm using could be 3.7. Other IDEs might have 3.9, 3.2, and so on. So therefore, Google Colab will have all the updated versions of Python. So therefore, use Google Colab for solving your assignments, especially for business analytics course. All your assignments, if you're doing it in Python, use only Google Colab. That is one.
So we have to apply Google Colab, or it will be multiple choice kind of question?
It will be a multiple choice kind of question.
Okay.
Sir, I have a doubt.
Yes.
For answering that one, you got to run the Google Colab, is it?
Okay, let me stop sharing this screen and then you can ask me. Yes, please tell me.
No, you said it's the multiple choice questions.
Hmm.
For answering the multiple choice questions, we have to run the Google Colab.
Yes, exactly. So we'll give you a data set. You will have to run the data set, and we'll give you a particular problem. It could be goodness of fit, or test of independence, or simple linear regression. So we'll give you some problem and data set. You will have to run the data set, get the answers, and you will have to enter your answers in the assignment portal.
Are you going to give some practice problems after that the assignment, or you straight away going to jump in the assignment?
So just now I covered one particular problem. So this is simple linear regression, and similarly,
for us to practice and test the assignment problem, we need to have some practice, no?
Yes, I understand your concern. So this will be mostly Python-based assignment. So you already have tutorials recorded and put in the course portal. For example, if you look at goodness of fit, guessing the distribution week 2, we have made 3 separate tutorials, I guess, one for uniform, Poisson, normal, and so on.
Sir, one tutorial is missing over there. Poisson is there, uniform is there, normal one is missing. Only 2 tutorials are there. At the start of the lecture, you said, you and sir said that, today we are going to discuss 3 data types, right?
Okay.
But the first one is a very lengthy discussion where it was that Poisson kind of thing, right?
Okay.
And then second video is very sort of only 9-minute duration. It is then there you are talking about the uniform distribution.
Okay.
And in that video you are saying that we have already seen Poisson and normal. So normal one is missing, sir.
Okay. So I think we might have to record it again. That got lost somewhere. We were also searching. So
Yes,
one hint is that you won't be getting normal distribution for the assignment. We will also not ask it for.
no problem. So I just highlighted you. Nothing else.
Yes. We will note it down. We will record a separate
Yes.
tutorial on guessing the distribution and checking for normal distribution. Sure.
So,
So
one
the other
question.
gentleman, Subramanian sir, was asking about the assignment thing. So you have
But sir, before that, I don't see any tutorials in week 2.
week 2, really? Can others check?
Subramanian ji, it is
It
there.
didn't tell about. It didn't call that as a tutorial, but it is giving guessing the distribution data
No,
set.
it is there. Lecture number 2.4 and 2.5 is referring those two one as tutorials. You know,
Yes.
up to lecture number 2.3, professor is teaching us, and then these people have chipped in lecture
But it is
2.4.
not named as tutorial, no?
No, they have not named it as tutorial. The title is that guessing the distribution of dataset 1 and guessing the distribution of dataset 2. So the first one is talking about
No, what I was telling that it is not called as tutorial. Do you have
Okay.
something else as tutorial? Then?
No. We call it tutorial, but that is the thing. So what?
in continuation. It is in continuation as 2.4 and 2.5.
Yes, it is a part of the course. You don't have to treat it as a tutorial. Maybe I just wrongly said it as tutorial. It is part of the course. These videos are already uploaded. Your assignment will be in line with those videos. So we will not complicate whatever you.
You have a
Yes.
practice assignment in week 1,
Mm.
but nothing on week 2. And
Because week two is mostly Python based, right? You want a separate data set, and you could generate all those things because it is very simple. You go to Excel, then generate some random numbers in normal, uniform, and then you can try it yourself. It's not a big deal.
all right, we'll try it.
Yes. So I see a person raising hand, Krishna Priya Kandan. Yes, please go ahead.
Yes, sir. Am I audible?
Yes.
Okay. So yeah, I understood like we'll have an assignment next week. By
Yeah.
that it means like will it be before our quiz one or how will it be, sir?
It will be released next week, but you will have some time to do that. There won't be any immediate ask for submitting the assignment. Let me check, and I think it will be there in the course. Course.
Grading document, right?
Yes, grading document. It will be available.
Okay. Okay, sir. Okay. Thank you.
Sir, so there will be 3 assignments and we best,
Yes. You will have 3 assignments. I think best of 2
out
will be
best 2 out of 3 will be considered, right?
exactly.
So these contribute 40 marks and 20 marks will be quiz, right?
So 2 assignments will contribute to 40 marks,
And
and then
end term is 40 marks and
yes.
quizzes are contributing 20 marks, right?
Yes.
Okay.
I think, and for next week, I will try to invite Professor Rahul. I think by next week, you would have done a little more advanced topics like multivariate regression and all.
Yes.
I think it's a good time to invite Professor Rahul.
So do you have anything else to cover today?
No, that is all, sir.
So I have couple of questions, sir. So may I ask?
Which one in week 2, week 1 and all?
Just a very few questions. Couple of very like one has already been answered. I highlighted you that that one of the tutorial is missing, like
Okay.
normal. So that is missing. That part is done, sir. Couple of
Okay.
questions, sir. Sir, like just a second.
Sir, in between I have a question.
Yeah, please go ahead. Yeah.
Sir, if you given a contingency table,
Mm.
we have to find
Mm.
chi-square test statistic, right?
Yes.
Without giving contingency table, how to find chi-square value?
I think it will be provided. So first thing is
Only they give price and demand, expected demand. How to find the chi-square value? Sir?
So I think in this course you will be provided with the chi-square table. You don't have to worry about that. But generally, you will have to look at the business problem, understand what is what. Maybe you might have to construct the contingency table yourself in the future. But as far as this course is concerned,
Quiz question, sir. Quiz question.
is it a quiz question?
Is one question. If the
Okay.
price of the items is given and expected demand is given, calculate the test chi-square test statistic.
Oh, is it in practice problem?
Quiz question, sir.
Okay, quiz question. Okay, I think Malolan might be able to answer because this was his question. Can you post it on the discourse forum? I will also look at this. I'll understand this better, and I'll be able to answer this question there.
Okay, next another question.
Hmm.
Coefficient of variation is standard deviation by mean value, right?
Yes.
For coefficient of variation for Poisson distribution is,
You should tell me.
that is 1, right?
Yes.
Is coefficient of variation changes for different distributions?
Yes, because the mean and variance will also change, right?
For exponential distribution?
Sorry?
Exponential distribution?
Yes, you should tell me what it is. What is the mean of the exponential distribution? What is the standard deviation of
1
the
by
distribution?
lambda, right? Mean is 1 by lambda.
Yes.
Variance is 1 by lambda square.
Yes.
It's also same, right, sir? Same
What?
like Poisson distribution.
This is lambda square, right? 1 by lambda square.
That is coefficient of variation is a standard deviation by mean, square root
Okay.
of variance.
Yes, I think you are correct.
For Poisson distribution, exponential distribution, both have same value.
Yes.
Again, I have doubts. That summary output, sir explained in lecture. There is a summary output, right?
Okay. For which one? The regression?
Linear regression.
Yes. Please tell me.
Is the correlation coefficient, how to find the correlation coefficient is positive or negative from the summary output?
Correlation. Okay. From the summary output.
Yes, yes.
It will be given, right? You will have whether negative sign will be given if it is negative.
No, sir, I have confusion.
Okay, so do one thing. I think the Excel files are there. Just run it. Download the Excel file. Go to the plugin, data analytics plugin, then run it. But this question here focus more on the Python part because most of your assignments will be on the Python. The Excel thing is just to give you an understanding how this is actually working. But in mostly whatever we are going to grade you is based on the Python coding. So here, if you look at the coefficient, so I just did a small tutorial here. So here, if you look at this particular problem, is my screen visible?
Yes, sir, visible.
Yeah. So this is the slope, and this is the intercept. So right, you have a negative sign here. Yeah. So this will tell you that the intercept is minus, and your slope is 828.
Okay.
So Excel was just to give you an understanding of how it is actually working. So generally what will happen if we directly just run the code in Python step by step and show you, you may not get the intuitive understanding of what is happening. So therefore, sir was plotting all the correlation between X and Y and then squaring it and then giving you an understanding of what is happening in simple linear regression.
Okay. Again, the degrees of freedom is changes with different distributions.
Yes, definitely.
Okay. What?
So it depends on the parameters. For example, the parameter for Poisson is, what is the parameter for Poisson?
One.
For uniform distribution, it is 0.
0.
For normal, it is 2.
2. Okay. 2.
Yeah. So it varies from distribution to distribution.
Okay. So what is the formula, sir? Number of buckets minus
K minus P minus 1. K minus P minus 1.
Minus 1. P means parameters, right?
Yes, madam.
But sir wrote number of rows minus 1, number of columns minus 1.
No, this is for regression. So regression, you will work it differently. What I was telling you was for the distributions problem. So if you are calculating degrees of freedom for a particular distribution, let us say Poisson, first K is the buckets, and then P is the parameter.
It means size of the data points, right?
Yes, you're correct. It depends on distribution to distribution.
Okay, thank you.
Most welcome.
So now may I?
Yes, sir.
Yeah.
Ganga Prasad.
Yes, sir, Professor, where we are talking about the empirical distributions, right?
Hmm.
So there, sir has spoken about Kelvin category. So what is mean by Kelvin category, sir?
Kelvin category.
Yes, sir.
KELVIN.
Yes, yes. He has not written anything. He just said that wherever those we are not matching it with theoretical distribution, we
Uh-huh.
develop our own distribution, empirical distribution,
Uh-huh.
which belongs to Kelvin category. Of course, he said that nothing to worry about Kelvin category at this point of time. We are not going to cover that. So, but I'm asking any brief idea what is that Kelvin category. Otherwise, I can move ahead. No problem in this.
No, I think this might confuse people. So generally, if you go collect data from the
Right.
field, right?
Right.
So let us say, I'll take a simple example. If you go to the ATM and you
Right.
count the number of people coming within a particular hour, right? So you will get some data.
Hmm.
So the data you collect may not necessarily follow a theoretical distribution.
Hmm.
So theoretical distributions are nothing but these Poisson, uniform, normal,
Right,
whatever you
right,
have
right.
theoretically, where you have a formula,
Yeah,
mean,
exponential and
variance.
all. Right, right.
Yes, but the field data sometimes it may not actually follow a particular theoretical distribution.
Yes, yes.
So if you understand that for now, it is enough. But so
Kelvin,
I'll tell you one more thing. The reason why sir is telling you certain keywords
Hmm.
is that you will Google it sometime and understand it for your own understanding.
Okay,
So that will help you.
I will also explore it, sir. If I don't get, then I will trouble you again next
Sure,
week.
sure. Please post it on the discourse forum, and
And so
maybe
what is what
yeah.
is standard error of skewness, sir? When we are doing that summary of descriptive statistics,
Hmm.
so there is one item named standard error of skewness, right?
Yes.
What is that, sir? What is standard error of skewness?
Okay. So in this particular regression problem, sir has specifically spoken about the standard error. So he has actually calculated from the data. He has taken the Excel sheet. He has data, and he has computed the standard error. It will give you good understanding. Please go through that lecture.
Yeah, to be very honest, I am just left with only those last two videos, sir.
So watch that video. He has
Yes.
beautifully
So where
spoken about that.
he's talking about standard error of skewness or standard error as a whole?
Standard error as a whole.
Okay. Okay, so let me watch that also, and then I will. And
Sure.
what is this Lexis ratio, sir? Lexis ratio?
Lexis ratio.
LEXIS,
That is for
Lexis
discrete
ratio.
distributions.
Yeah, that much only is, he has mentioned.
Coefficient of variation for discrete distributions are
Yeah,
only
that much only has written, same as coefficient of variance for discrete distribution, right? Any other insight? Any other insight? Anyone can help me.
no same doubt.
Yeah. So that's good that my question may help.
So these things I think you can Google, because these are not used on day-to-day basis at industry or the academics. Sometimes you will have these interesting concepts. If you find it interesting, fascinating, just do some more Google research and write a small article in the discourse. We will also read it. We will also understand it from you people.
Okay, no problem, sir. You people are more intelligent than us. No problem, sir. Sir, now every lecture is just interconnected with each other.
Yes.
So where we started talking about goodness of fit, right?
Yeah.
So before ending the lecture, professor said that there are two ways to check goodness of fit. One is chi-square test, and the other is Kolmogorov, right?
Yes, it is called KS test, Kolmogorov-Smirnov test.
Smirnov test. So
Yeah.
KS test, right? So before ending at this point, he said that but before proceeding these two tests, we have to check for independence, right? He said that before proceeding for these two tests, we have to check for independence. And then the next lecture, itself, after that, there are two tutorials. And then week 3, he starts directly with the, for independence, he is using chi-square test itself.
Yes.
So I am not clear whether before proceeding for chi-square, we have to do independence test, and chi-square itself is done for independence test. So, slightly confusion.
No. Just focus on this chi-square test of if you want to calculate this, use only chi-square test of independence. The idea is why sir introduced Kolmogorov-Smirnov test was twofold.
No, I am not talking about KS test, sir. Even for chi-square test, he said that before proceeding for chi-square test, we have to check for independence, right?
Yeah.
He made this statement. He said we have to check for independence, but he didn't say that how we are going to check independence. In
Okay.
week 3, he is starting with chi-square test of independence directly, right?
Yeah.
So now,
Yeah.
now I'm slightly confused. In order to check the
Mm.
independence, we are using chi-square itself. Whereas before using chi-square, we have been asked to check for independence. So it is looking something circular kind of thing. So
Okay. I'll again check why. I'm not sure why sir mentioned that. So let me check and get back
yeah,
to
it,
you.
it is in lecture 2.3, sir. You can note it down towards the end.
Yeah.
Sir has mentioned guessing the distribution. It's a small video, sir.
Okay.
So
So I'll check. I'm not sure on what context sir mentioned this.
yeah,
Let me again check. But that was a good question. What you said.
Right.
So there are ways to statistically test a distribution. You could
Right.
use chi-square test of chi-square goodness of fit, and then Kolmogorov-Smirnov test. So what sir actually wanted was, so we introduced this chi-square goodness of fit test. So if you look at some data, you will guess what distribution it comes from, what is the parent distribution. And once you guess the distribution, you will statistically test it again and confirm that this comes from Poisson, normal, or uniform, and so on. One way to do that is chi-square goodness of fit.
Correct.
Sir intentionally did not cover Kolmogorov-Smirnov test because the idea is to give you some intuition about what is this goodness of fit is about. Sir wanted you to explore Kolmogorov-Smirnov test and learn it at your own convenience. So this course will not cover KS test, but
yes, we'll catch up. We'll catch up with that, sir.
yes.
But this is the point which was troubling me. That before proceeding for these two tests, he has asked to check for independence, and for
Okay.
independence itself, he is using chi-square test. So I am slightly confused over there.
Yeah. I will look at that.
Yeah. Answer then. When we are finding this expected frequency while using that chi-square test for independence, we are calculating expected frequency, right?
Yeah.
One is the observed frequency and the other one is the expected frequency. So where we are using the formula row total into column total divided total sample size. So how we are deriving this formula, sir? Like what is the rationale behind it? Because frequency part is clear, it is nothing but the it's a ratio. The denominator is basically the total number and the numerator is basically the observed value, right?
Okay.
So here we are multiplying row total into column total. The moment we are multiplying row total into column total, it will give us a very big number, right? Say for example, 500 data points are there in row and 500, it's a column total. So it will give us 25,000 or even more. 250,000, right? So
Okay.
from where, what is the how this formula is derived, sir? Could you throw some light on this?
I think Malolan is the right person. He was doing this particular week. I'll again check this particular thing. So I'm not able to see what sir has spoken in this tutorial. So therefore this week, from this week onwards, I am taking out.
Could you please write it down also, sir, so that you
Sure. So observed minus expected. Sure.
No, I'm not saying observed minus expected. I'm saying the formula of expected frequency is row total into column total divided by total sample size.
Okay.
So how this formula is derived? That's what I want to know. And so technically, what is being what do we understand when we say statistical independence? So what is meant by statistical independence?
Sure. I will note down these two, and I'll have a word with Malolan because he was doing this week. And so these formula and statistical independence, I'll update it on the discourse board.
Okay.
So, I wanted to focus more on week 4. So these was covered in the last live session, I guess, week 3. So therefore,
record. No, sir. I do. Okay, that's fine. But recording is not available.
Okay. I'll make sure.
I don't think that whether these points have been covered or not. So,
okay.
Because I cross-checked with a couple of people who had attended, so I am not sure.
Sure. So two things we'll do. One thing is there seems to be some doubts in the chi-square independence thing. So one thing we can do is next week, sir will also be available. Rahul sir is also coming. So he will also give you some understanding on all these things. And meanwhile, I'll also make sure that the previous live sessions are uploaded. And then few questions which I had noted down.
Correction in the name of the YouTube channel.
Yeah, sure.
So, sir, coming to week 4, sir. So, sir has spoken about consumer surplus, right? So, could you explain that term itself? Like latent demand, that part is clear. As we reduce the price, demand increases, right?
Yes.
So, whatever additional demand is created by reducing the price, that is called latent demand, right? So what is consumer surplus, sir? One thing is clear that as we increase the price, my demand decreases, right?
Yes.
So then what is surplus here? Then what is surplus here? So what is meant by consumer surplus?
Consumer surplus.
Yeah, these two terms he has used, latent demand and consumer surplus.
All right. So it gets into microeconomic theory. So here surplus is nothing but you can say the customer utility, how it is increasing. So these all go into microeconomic theory. So all these surplus, profit, utility, and all those things, these get into microeconomic theory. I don't know how much of all these things are needed. So here, if the price is getting reduced, let us say from 20 rupees to 18 rupees. So
my
this
demand will increase.
Yes, the 20 to 18 there is a price reduction. This 2 is the customer surplus. I think right now you don't have to worry much about this because these are all classical economics concepts.
No, I'm also from the exam point of view. We should not, if we get some question related to this, so that's the problem. Nothing else. So anyhow, you can write it down also, sir. That's all. So that's all from my side, sir. So whatever questions we have discussed, if you can, just throw some light on that, so that will be a great help.
Sure.
Sir, I have one clarification question in 4.2. Can I ask?
Industry 4.2?
Yes, sir. Elasticity formula.
And I think Jaimini will handle that Industry 4.2.
Oh, okay, sir.
So because this, I think you have a separate session for Industry 4.2, I guess.
Not Industry 4.2. I think week 4 4.2 lecture I'm talking about.
Okay. So week 4, please tell me.
Okay, sir. Week 4 4.2 lecture, there is a formula for elasticity actually. And in that formula, indicate that ratio of percentage change in demand divided with the ratio of percentage in price. There is a negative sign before it. Should we always use that negative sign, sir? And what does it indicate actually, the negative sign there?
Okay, there is a negative sign.
Huh.
So that I don't think there is a negative sign because it is a...
the lecture has it, sir, actually.
Yes, it is negative sign, sir.
Okay, I'll also check. I think it shouldn't be there.
Actually, in medium we have, right?
Can I give a try here? Hello, Rajesh, can I give a try here?
Yes.
Yeah, I think someone was rightly saying that in BDM also this concept was there. So it has been mentioned that the sign will always be there, but while communicating or while talking, we have to drop that sign. Because
because price elasticity is always negative.
Yes, price elasticity is always negative, but while we communicating, so we have to drop that sign. So it is as per the definition. It is standard definition. So that's the reason why that sign is there.
Okay, interesting. I'm learning these things. All right, so I think next week Rahul sir will have you can save these questions a little more for a little more time. Sir will be here, and you can ask all these concepts, all these questions to Professor Rahul.
Sir, it's a 12-week course or 8-week course, sir?
It's a 12-week course. So right now you are in week 4.
We are in week 4, but somewhere in dashboard of where I was just going through the content part. So only up to week 8 it has been updated that what are we going to learn. So the content is given only up to week 8. So I was worried the results are
the course content is.
Alan sir was saying one time that it is not updated, and he said he'll get into it.
So
okay, I had missed that part. Sorry.
Okay, so I'll tell you what all you will go through. So now it is simple linear regression. Next you will be introduced to multiple linear regression. Then comes logistic regression or classification problem. And once logistic regression is done, I think you will work on concepts like data envelopment analysis, conjoint analysis. Yes, I think it's a 12-week, definitely it's a 12-week course. So these are the concepts you will be learning in the upcoming weeks.
Are you planning to cover
Currently the course content is...
Sorry,
sir?
Currently the course content is listed for 8 weeks.
8 weeks? No, I think it is definitely a 12-week course.
Sir, are we covering econometrics also here, sir? Like that is also...
No.
Okay.
No.
There's no project, no?
No. You don't have project here.
So 2 assignment marks in term
end term and quiz 1, quiz 2.
Quiz 1 and quiz 2.
Hmm.
No, that is an end term. No, quiz 2 is an end term, is it?
Yes.
So quiz 1 only.
No, 2 quizzes are there, na? 26th
have two
February
quizzes.
and 2nd of April.
Quiz 1, quiz 2, and
Yeah,
end term.
Yes.
and then end term.
Yes.
Okay, very confused.
All right, guys. I think we can close it.
Yes,
So next week, Malolan will be here. Rahul sir might also join us. We can have
So
good
try to take a
discussions.
note of those points and what we discussed.
Yeah, sure. We'll update it on the discourse forum.
Yeah, yes, sir. Okay.
Thank you.
Thank you, sir.
Thank you. Thanks, sir.
Yeah. Bye.
Thank you, sir.
Thank you, sir.
Bye.
Thank you, sir.
Thank you.